Hello, my name is Judd White. This is the third video in a series where I'll be covering the fundamentals of C# using Visual Studio 2010. In this video, I'll cover variables, data types, and operators. My email is jwhite@cdti.com. Feel free to write me there. My website, which you can see on the screen, is judsonwhite.com. On there you can see a little more about me, my resume, some open source projects I work on, and stuff like that. And all these videos will be posted to judsonwhite.com/learn. At the end of the last video, I mentioned I'd be working with receiving user input and debugging. Unfortunately, this video is already on the long side, and a lot of attention deserves to be paid to data types, and so I'll cover those topics in the next video. So, start off by opening Visual Studio and go to File, New Project, select Console Application, and we'll call this one Variables. So I'm going to start off by writing the code, and then I'll explain what's going on. So let's run it, and it prints the number 42 and gives us its perspective on that number. So what's a variable? A variable is a place to store data. That's all it is. The data may be simple, like the number 42, or it could be complex. We'll start simple and work our way up, but either way, a variable just stores data. The syntax for declaring a variable is on line 12 here. We start with the data type, which in this case is int, which is short for integer, followed by a space and the name of the variable. The name of the variable is up to us with a few rules. The variable name can be anything that consists of letters, numbers, and underscores, as long as it starts with a letter or underscore and is not a reserved word. Now, a reserved word is a word with special meaning to the compiler. For example, namespace, class, static, void, string, int. Essentially anything that you see that's blue on the screen here. I'll show you a quick example of a few valid and invalid variable names. So the first three are valid, but the last three aren't. First number is invalid because it starts with a digit. My number is not valid because it contains a character which is not a letter, number, or underscore. And abstract is invalid because abstract is a reserved word for C#. Now, technically, you can escape a reserved word with an @ sign, but if you do that, your coworkers are probably going to laugh at you or worse. I'll show you an example so you're familiar with it, just in case you ever run into it. So I'm going to delete the other variable declarations and keep int abstract. And actually I'm going to change this to a string. And I'm going to add an @ sign. And I'm going to assign a value to it. And console.writeLine. And now I'm going to run it. And there you go. Don't do it. The convention for naming a variable is to first give it a meaningful name. Don't use variable names like A, B, etc., at least not in production code. You want your code to be readable later on. Also, use what's called Camel Case, which means start the variable with a lowercase letter and each new word starts with an uppercase letter. For example, in my number, the leading M in my is lowercase and the N is uppercase. This casing convention applies to local variables and method parameters, such as args up here. For class names like program and console, and for method names like main and WriteLine, these follow a naming convention called Pascal case, and the difference is that the first character is capitalized. There are other types of elements you can create and name in .NET, and we'll talk about their naming convention as we cover them. Basically everything else is Pascal case with the exception of private and protected fields, which we'll talk about when we discuss classes. The advantage of adopting this naming convention is it's consistent with the naming convention of types that are built into the .NET framework and how other developers do their naming. Our next line is my number equals 42. What's going on here is that this line stores the integer 42 into our variable, which we've named my number. Technically, it copies the value 42 to the memory location which has been allocated for the variable my number, which will make more sense when we talk about the difference between value types and reference types. Lastly, we write out the number. If we hover over the WriteLine area, it tells us which overload of WriteLine we're calling, or which version of WriteLine we're calling. We can see it's calling the overload which takes an int parameter. If you recall from one of the previous videos, there's many different versions of WriteLine. We can see them by going inside here, hitting Control-Shift-Space, and there's quite a few. But the one that we're using here is the one that takes a single integer value. Also, if we hover over the WriteLine where we're writing out that's an excellent number, we can see that this one is calling the overload which takes a single string value. So let me show you a shortcut for declaring and assigning a variable. Delete the line my number equals 42, and let's look at the error that we get. So it's telling us use of unassigned local variable my number. In C#, unlike C and C++, the compiler forces you to assign a value to a variable before you can use it. This is a common problem in the other languages because without assigning a value, you'd get a random value, which can sometimes be subtle and difficult to track down. Okay, now the shortcut is to join the variable declaration int my number with equals 42. This has the same effect as before, and if we run our program, we can see that nothing's changed. Okay. Now, there's a number of built-in data types in C#. Let me pull up MSDN real quick and show you. So here's the list. The ones that you'll most commonly use are int, long, double, decimal, char, string, bool, and object, and maybe byte, depending on what you're doing. So let me talk about each one of these real quick. A byte is 8 bits, and its range is 0 to 255. And one thing I can show you real quick is that this range actually does have a meaning to the number of bits that the data type can store. So for example, byte here is 0 to 255, and it's 8 bits. So one way to look at that is to say 2 to the 8th, and then minus 1, 255. And that's the reason why it can store between 0 and 255. I won't do the other ones, but they all run the same way. S-byte is a signed byte. It allows negative numbers. Short is a 16-bit value. U-short is unsigned. Again, no negative numbers, but you get the advantage of a higher positive number. Int is probably one of the most common data types that you'll use. It's 32 bits. One thing to note is that in some other languages, int is a variable depending, meaning variable in length. It could be 32 bits or 64 bits depending on which operating system you're running on. The .NET framework, if it's an int, it's 32 bits, that's it. It doesn't matter if you're on a 64-bit system or not. uint, again, is also 32 bits, but excludes the negative numbers. Long is 64 bits. It works a lot like int, except you get a larger range. ulong, again, lose the negative numbers, get a higher positive number. A float is a single precision floating decimal. It's relatively unused today, at least in my experience. It could be used for interoperating with other code if you're using DLL import, or possibly if you're making some calls to a COM component or into the Windows API. Double is kind of the more common. It's double precision. It's sometimes used for math, but you should be a little careful about using double because it does have a limitation in its precision. It's appropriate to use if you're calculating graphics, like a lot of WPF is all the positions, margins, offsets, and widths, heights, all that stuff. It's all done in double, which is good enough for graphics. Where double is not really good enough, at least not in my experience, is for anytime you're working with money. You don't want a rounding error, especially if your business is subject to auditing. So decimal is it's more precise. You're not going to get rounding errors. It works for one example is work in the banking industry. We have points that go out to 8 decimal points or even further, and this handles it without a problem. Now, char or care, or some people say car. Some people say care because it's short for character. I say char. So char is it's a single text character, like the letter A or the letter B. And one thing to note, it's different from C and C++ if you happen to have that background, is that it's a Unicode character as opposed to like a wide char or something like that. It's always 2 bytes. It's UTF-16, 16 bits, 2 bytes, and stores a character. String is a string of characters. It could be 0, 1, or many characters. It's also, every character is encoded the same way. It's UTF-16, so every character inside of a string is also 2 bytes. Bool is for determining if something is true or false. We'll talk about that coming up shortly when we talk about controlling program flow. And object is it's the root of everything. It's everything in .NET is an object, and it deserves a special discussion as well. Now, if you ever want to come back here, just do a Google search for C# data types, and I believe it's the second link here, which takes you here. Yeah, okay. Also, one last thing to talk about with data types is that the unsigned version of these are not what's called CLS compliant, or Common Language Specification. The CLS is kind of the bare minimum requirements that any language has to support in order to be considered and condoned by Microsoft to be an official .NET language. So unsigned values are not part of the requirements for CLS compliance. And one thing to note is that if you're creating a class library and you want other .NET developers to consume your library, they either have to be using C# as well, or some other .NET language which does support unsigned numbers, and particularly Visual Basic does not. So keep that in mind. So let's go back to Visual Studio, and I'm just going to go ahead and delete everything that's in here, and we're going to talk about operators. So what we get is the basic operators that we remember from school. It's plus, minus, times. The times operator is the star or shift 8 or asterisk, divide, and modulo. And modulo is remainder. For example, if you had 20 modulo 3, this would equal 2, because 20 divided by 3 is 6, and that gives you a remainder of 2. So the order of operations are also respected. So if you're writing something such as this, the order of operations, remember PEMDAs, are all respected. So the 3 times 2 is going to happen first, and then you're going to get the plus 4. The exception is the exponent, because we don't have that as a built-in operator. So first I'm going to work with integers. So I'm going to write out this code. And through the magic of video, we have all of our code written. So first thing is that there's a new thing up here, and that's a string format. And we'll talk about that real quick. So what I have inside here is, this is maybe our IntelliSense will tell us. So this is the format, and then it's followed by a list of parameters. So what I have here is these curly braces with a number. This number is the index of the parameter that I want to appear in my string. It'll probably be more apparent once I actually run the program. So 0 here refers to the first parameter, 1 here refers to the second parameter, 2 to the third parameter, so on. it's kind of a nice way to show what your intent is, and then just supply the variables everywhere else, as opposed to, if I was to write, a plus yeah. So in my opinion, the string format is preferable to this style. So let's think about what we expect the results to be, and then we'll take a look at what they actually are. So we have two integers, a and b, and we're doing some operations on them. So a plus b, we expect that to be 5. A minus b, we expect that to be 1. A times b, expect that to be 6. A divided by b, we expect 1.5, maybe. A mod b, let's see, that would be 3 divided by 2, and that'd be the remainder. That's going to be 1. And then here we have a divided by b times b. And normally you would think that the b's would cancel out and you just come out with 3, but we'll take a look at what happens there too. So let's run it and move this so we can see what operations we're doing. Alright, so 3 plus 2 equals 5, yeah. 3 minus 2 equals 1, yes. 3 times 2 equals 6, okay. 3 divided by 2 equals 1, alright, that's weird. 3 mod 2 equals 1, we figured that one out. And 3 divided by 2 times 2 equals 2, okay, definitely weird. So we got two kind of problem statements, and they both relate to division. So let me talk about what's actually going on here. So when you divide an integer by another integer, you get an integer. You can't expect this to be a double or a decimal or anything else. It's kind of just the way it works. So what happens is when I take a, which is 3, and divide it by 2, I get 1, because it's 1.5, and then it rounds down, or technically it rounds closest to 0. I'll talk about that in a second. Alright, so 1.5 rounded closer to 0 is 1. And then over here I have a divided by b again, so that's 1.5 rounded to 1 times b, which is 2. So now that we know this, we expect this to be 1, and we expect this to be 2, and that's consistent with what we actually see. So when I say that the rounding happens closest to 0, if this a was -3 instead, and I do, okay, -3 divided by 2 is -1.5. If I said it rounds down, that would mean it would round down to -2. But it doesn't. It rounds closest to 0. So we get -3 divided by 2, which would normally equal -1.5, equals -1. So I'm going to change that back. Now, what can I do to get real values here that kind of makes sense? Well, I can change everything to a double, and that might actually be a good thing to do. So I can go ahead and hit Control H to do that, by the way. Say replace all. And if I run it, okay, that actually looks pretty good. Now, what if just my results were doubles and a and b were integers? What would happen then? Alright, let's take a look. So, looks good, looks good, looks good, doesn't look good, looks good, also doesn't look good. So again, we have a problem with our division. And what's going on is that on this side, we're still having two integers being involved in division. So the compiler doesn't really know what's where this value is going to be stored. So it does integer division. So it does 3 divided by 2, and it comes up with an integer result of 1. And then it goes ahead and throws it into the variable, our result 4, so it still comes out 1. So that's why we have a problem here. And we can do something to fix this. We can, before we just changed everything to double, and it worked out just great. We can also do what's called a cast, and I'll show you how to do that. So what I did was I put the type that I want to convert b to in front of b, and then I enclose that type name in parentheses. So I'm saying I want to turn b into a double. So let's run this and see what happens. Alright, that's a lot better. So we get our 1.5 now, And the reason for that is because when you involve an integer and a double inside of an operation, you get the more specific value, which is the double. Now let's go down here and try the same thing. And let's run it. Now I still have a problem here, and that's my 3 divided by 2 times 2 is still saying that it equals 2, even though I converted one of my variables to a double. And the reason is because it's doing this operation left to right. So still here I'm doing an integer divided by another integer, which results in an integer. So again, this results in 1, and then I multiply it by a double 2, which still gives us 2. So this casting is happening too late. So I could put it here, or I could put it in front of the A, and I run it again, and now I get a value that actually looks good. Now that we've talked about how to work with these integers and doubles together in variables, let's take a look at if we're just using straight numbers. So I'm going to say double result equals our familiar 3 divided by 2. I'm just going to write out the result. And again, we're getting our 1. The reason again is because whole numbers without a decimal point are considered integers, so we do an integer operation here. So we can fix it one way by making one of them a decimal. If we run this again, we get the value that we expect. The other way is to explicitly say that 2 is a decimal, and to do that we just put a D after it. And now we get our 1.5. This is actually one of the places in C# where it's not case sensitive. You could also use a capital D and get the same results. Alright, now what if we had decimal, our preferred data type for money? Probably no surprises on what the result's going to be. Just get our 1. Now what if we add our 0.0? We immediately get an error that's underlined, so let's hover over that. And it's complaining that it can't convert a double to a decimal. So like I said before, if you have a decimal point in your digit, you go to use it, it's going to be considered a double. So what we need to do here is we could also tell it that it's a decimal by casting. And we can run this. And we could also use the shortcut letter, which for decimal is M, which I think might be money. And this works as well. And again, capital M works as well. Now we've talked a lot about how to make what would normally be an integer a double or a decimal, but there can also be cases where I have a double and for some reason I want to convert it to an integer, and maybe I want to add to it. And there's an error here talking about that they cannot convert from a double to an int automatically. So what we would do here is we would just convert that result to int. And let's go ahead and right line result 2. So I'm expecting 1.5 and then 2. Alright, good. Now the other thing I could do here is say this was another double here, and I didn't want to go through the trouble of converting this as well to an integer. Actually, let's even say this was 1.5. So I'm first going to convert result, which is 1.5, to an integer, which is 1 when it gets converted, and then I'm also going to convert 1.5 to an integer, which is also 1. So I'm adding 1 and 1, I'm expecting to get 2 based on our conversions, which I do get. Now, what if I only want to round the total result? Well, I use the same thing, but I can apply it to a larger expression. So I wrap this up. So this operation happens as a double operation. So I'm going to get 1.5 plus 1.5, and I want to convert that to an int. So although I'm using the same result variable plus 1.5, I'm expecting a different answer, which I'm expecting to be 3. And another way to think about this is, what if I just said double result? Change my variable names. What if I just said result equals result plus 1? Then it would be obvious that if I wanted to assign result 3 equal to the value of result 2, that I'd have to do this. So this result 2 is really just the same thing that we had before. Excuse me. It's late. And there's our 3 again. So I encourage you to play with this because it can definitely be a little bit confusing on screen. Alright, I feel kind of bad for mentioning exponents when I was talking about PEMDAs and then I didn't show you how to use them, so let's do that real quick. It's math, which is a class that lives in system, and then dot, and there's a bunch of stuff in here. There's a constant for pi, there's a bunch of trig functions, and the one we want is pow, or power, which is our exponent. And I'm going to do 2 to the 8th power. Now you might be looking at this and going, oh, wait, it said it takes doubles, but you're passing integers. This is one of those conversions that it can do for you. And I'm going to say 2 to the 8th minus 1, and I'm going to assign this to a result. And then I'm going to... I got a problem and I'll fix that. Oh, no, it was just kidding. Sometimes it lags, and then it'll tell you, oh, just kidding, there's no real problem, you're good. Okay. And let's run it. Okay, so the air conditioning in my car is 255. And if that didn't get a laugh or a groan out of you, let me add console.writeLine. And let's run this. Okay, yep. Anyway, so again, I'm using string format. Now I didn't explicitly say string.format, although I certainly could have. Make this a little wider. And the reason is because WriteLine has a way that you don't have to say string format. I like to anyway, just to be consistent. So I casted this result to an int because I wanted an int to show up here. If I didn't do that, I would have had a double divided by an integer, which would have resulted in a double, and which would have made my lame joke even lamer because it wouldn't have made any sense. So that's why I did the cast here. So that does it for this video. In the next video, I'll cover working with user input, some conditional statements so you can control the flow of your program, make it do different things under different conditions, whether those conditions are user input or something else. And I also want to get into the debugging tools of Visual Studio so you can step through your code and see what's happening line by line as it executes. Okay, thanks again for watching.